Hey guys, welcome back to Michelle's version of calculus, and today I'm doing 7.3, which is going to be sketching slope fields. Personally, I actually hate doing this, anything with slope fields actually, but I'm going to try to explain this to the best of my capabilities, which is not much. Okay, so a slope field represents a differential equation on an xy plane, and it shows the shape for all particular solutions to a differential equation. Yeah, that doesn't make sense to me either. So you know how, like, when we found a general, again, just going back to Unit 6, the general equations, we had a plus c. And that plus c stood for any possible constant. Like, we did not know what it was at all. It could be anything. Because remember, taking the derivative of a constant will always give you 0. So when we're integrating and taking the antiderivative, we do not know what that value is. And so we would solve for it with a particular solution. However, slope fields, basically using, of course, we know the slope. So it quite literally just gives you every single possible line that it could be because of that plus c. So because of plus c, like let's say we had a graph that looked like it just looked a parabola. Because of plus c, we know that the slope of that parabola will be the same at every single place and point. Because of plus c, it could quite literally be at any single y value. Plus c's will basically usually make it only shift on in terms of y value, the y value / axis. It's going to just shift along there. And so slope fields basically gives you every single possible it gives you the slope of all particular solutions. And so I'm going to pull out big ways for this. I'm going to actually pull out my own notes I took. But as you can see here, below is a differential equation with its accompanying slope field. And again, because we have infinite selections of c, every single one of these points basically is giving you a possible option for this graph. And so we have dy over dx equals 2x. And we basically just plugged in a point right here. You can pick any point. This one that was chosen it says -1, 2. But it's definitely supposed to be -1, 1. Or actually, no, -2. -1, 2 works as well. I just circled the wrong point. But we have -1, 2. 2 times -1 is going to give you -2. Alright? And which is why our slope here is -2. As you can hopefully see. Our slope right here is -2. It's a very, again, it's going to be very, not perfect, but there's kind of a little hash mark right here that's going down in that direction. So yeah, that's kind of how that works. And the more hash marks you have in a slope field, the more accurate it's going to be. So as you can see down here, on this very bottom one, this is going to be a lot more accurate of a slope field because there are so many more hash marks. And I've already have it drawn out here, but when you're drawing out your slope fields, you're going to want to follow these hash marks similar to like a current. Think of a current or waves, a whole bunch of fish, whatever works for you, and just drawing it out. It won't be perfect for everyone. I definitely struggle a lot drawing these, but we're basically going to go ahead and solve a quick little practice problem. Based on this. So, here we are. We have a dy dx, which is the first one, equals x plus y. And so, basically, for each of these points, we're going to find the slope for each point. So, 0, 0, and we're just plugging it into here, every single x and y value. This is going to take a hot minute, so I will hopefully just kind of speed this up once I kind of show the first step. So, the way to do this is making a table of kind of just going through every single x and y. So we'll just start on the left and go this way. So we have -2. I just start here and I go down each row personally. So we're going to do all the -2 values first. 1, 2, 3, 4, 5. Their y values, so it goes from 2 to 1. 0, -1, -2. And then you're just going to do the math. So, -2 plus 2, 0. -2 plus 1, -1. This is -2. that is going to be -3, and that's going to be -4. As you can see here, our slope is continuously decreasing. And you would basically go ahead and do that for every single point on here. And I already solved this, so I'm just going to go ahead and hash them all out. So let's just do this first row together. So this would be flat line because it's 0. There is no change in slope there. This would be your typical 1. This would be a little bit steeper. This would be a little more steeper, and then by the time we got to -4, it'd basically be vertical. Or like almost vertical. I know these look the exact same, but they very much so are different slopes. And you would do this again, so -1 plus 2, that's going to be +1 this time. This zeroes out again. This is going to do that, and it's going to keep getting steeper and steeper. And so your final graph for this, I'm going to go ahead and you're quite literally, for this one, it's actually really great. You're just following these lines for these bottom ones. And then it starts to gradually just rise itself upwards. Almost vertical. Like that. Again, this will not look perfect, but you will get the gist. This one looks like that. This one, kind of like this. I'm kind of skipping around here. But as we can see, we can kind of guess what the graph would kind of look like. We kind of see that it's a little difficult, but it's going to look something similar like that. So yeah, that's kind of how, that's kind of how sketching slope fields work. So yeah, thank you.